This is a CCEA past paper question. We're going to do number 5 here from the A2 Pure Maths paper from 2022. It's on functions. So let's take a look at what we have. So the function f of x is defined by this, which is a quadratic. Express f of x in the form like that. This minus always kind of caused a bit of mayhem, so let's kind of rewrite it. So I would write f of x equal to minus upon x squared minus 3x minus 10, and then I'm just going to complete the square like that and then rearrange from there. So completing the square here, then we've got to go x, take away, and you take half of this, the 3 over 2, and then all squared. If we multiply that out, we would get an extra 3 over 2 times 3 over 2, sorry, minus 3 over 2 times minus 3 over 2, which gives us a 9 over 4. So we want to get rid of that. So minus 9 over 4 minus 10. Tidying that up, minus x minus 3 over 2 all squared, minus 9 over 4 minus 40 over 4 effectively is minus 49 over 4, and then integrate the minus back into this, so it will be minus upon x minus 3 over 2 all squared plus 49 over 4. Hence state the range of the function f of x. There's a couple of different ways of looking at this, but the biggest number this here bit here can be is 0. You can't get that to be any bigger than 0. So the biggest the whole thing can be then is 49 over 4. We've also kind of found the turning point, and it's a quadratic, but it's like an upside down quadratic, so it kind of looks just sort of vaguely like this here, and that then the point's 49 over 4. Another way of knowing then that that's going to be kind of the range, so it's anywhere where f of x is less than or equal to 49 over 4. State the domain for which f of x is a decreasing function. So again, I'm going to look back at this dodgy wee graph I have here. That there is the point 3 over 2. It's increasing until we hit this point here, and then it's decreasing then down like that. So anywhere where x is greater than or equal to 3 over 2 is what we're looking for, sorry, greater than 3 over 2, and that's what we want. So for part 3, x is greater than 3 over 2. Given f of x is that, so that's our kind of previous one, and g of x is this. Sketch the composite function g of f of x on the axis below, showing clearly any key points. So g of f of x, it means we lift out f of x and we substitute it into that. So our, let me see, I'm just going to do this below actually. So g of f of x is going to be the modulus of minus x squared plus 3x plus 10. There's a couple of different awkward wee kind of modulus ones. This one's not too bad, but it's effectively, we're going to take the graph of that quadratic, sort of the way I did it, and then we're going to reflect anything that's below the x-axis above the x-axis, and that's then what we're going to do. The other point is just kind of showing any key points. We kind of know that wee top point up there, that was our 3 over 2, 49 over 4, but we also need to kind of work out where it's crossing the axis, so we kind of do that down here as well. So minus x squared plus 3x plus 10 crosses the x-axis then whenever we put y equal to 0. I would again just rewrite that, x squared minus 3x minus 10 is 0, and that gives me x minus 5x plus 2. So my key points there are 5 and 2. So what do we know? We know it's a parabola. We know it's effectively upside down. Sorry, that's there's a minus 2. It crosses then at minus 2, and it crosses at 5, and then we have this point then up here. So what we would normally draw is this, but anything below then we reflect above. So it's going to be that. That's minus 2. That's 5. That's 3 over 2. And that then is 49 over 4. I suppose technically another key point is going to be this one here. And if we put x equal to 0 in this function here, if you kind of have it there, then you're going to get 10, which would then be kind of this wee point here. And that's the function we're looking for.